Hi everyone. So last week we focused on how to graph linear equations we reviewed. Now this week we're going to move on how to graph quadratic functions. So if you can recall back to our functions unit, the standard form for a quadratic equation is f of x equals ax squared plus bx plus c. And what makes something quadratic is that there's something being squared. Okay, so if we see an x squared, we know it's a quadratic function. So we're just going to talk about the main pieces of a quadratic function, such as its shape, the axis of symmetry, and the vertex. Okay, so let's start with the shape. There are two types of shapes. Okay, so remember that all quadratic functions, when you graph them, they create a parabola, right? So we either have our smile or we have our frown. So if I graph each of these, which I'm going to do right now, so you can see this first parabola, if I connect all the points with one smooth line, the parabola is opening upwards. If I connect these points, you can see that the parabola is opening downwards. So those are our two possible shapes that we could have for a quadratic function. All parabolas have what's called the axis of symmetry. So it's basically a line that goes straight down the parabola and cuts it in half. So if you want to highlight, cuts the parabola in half. And the equation of the axis of symmetry is always going to be x equals some number. So you have to figure out what that number is going to be. So if I look at the first one, if I find the line that goes straight down and cuts the parabola in half, I'm always going to highlight it in blue. This is a vertical line. So remember, all vertical lines have the equation x equals. We did this when we graphed linear equations. So we just have to figure out what the number is. Well, where am I crossing the x-axis? I'm crossing at 0. So this equation is x equals 0. For the next one, again, I want to figure out where can I split it in half. So there is the halfway point. And again, I want to figure out where am I crossing the x-axis. So it's 1, -2. So the equation of this axis of symmetry is x equals -2. So see if you can figure out what would be the axis of symmetry for the last one. Well, if we go straight down the middle, there's my line. And now I'm going to count. Where do I cross the x-axis? 1, 2, 3. So the axis of symmetry is x equals 3. So besides shape and an axis of symmetry, every single parabola has what's called a vertex. And that vertex can either be a maximum or a minimum. So what do I mean by that? A maximum is the highest point that the parabola hits. And a minimum is the lowest point that a parabola hits. Okay, so you either have one or the other. The axis of symmetry intersects a parabola at only one point, that vertex. So if I go back up here, I could show you that these blue lines were going through the vertex. So let's look here. What do we think the vertex of this graph would be? Well, it's where the graph turns. So it's coming down, stopping, and then turning and going back up. So this turning point right here is my vertex, and that is the point 0, 2. Since this parabola is coming down, it hits its lowest and goes back up. Since it's the lowest point, we would call this a minimum. For the second graph, I'm going up, I'm going up, I'm going up, I'm stopping, I'm turning and I'm going straight back down. So that would be my vertex, and that is the point -2, 0. Since it's going up, it's hitting its highest point and going back down, this would be called what? A maximum. So just to recap, every quadratic function is something that has a squared in it. They form what are called parabolas, and they either open upwards or downwards. Every parabola has an axis of symmetry, a line that goes straight through the vertex and cuts it in half. And the vertex can either be a minimum, which is the lowest point, or a maximum, which is the highest point. So now that you know the main pieces of a quadratic function, we're going to focus on how to graph them. And in order to graph them, we're going to use vertex form. So the general form for vertex form is f of x equals a times x minus h squared plus k. Now, what do all those pieces mean? So a is going to tell us if the parabola opens up or down. So let's write that down. A tells us if the parabola opens up or down. So it's either going to be positive or negative. So think about it. If A is going to be positive, do you think it's going to open up or down? Well, it opens up. Think positive, you're happy, smile, it opens up. If A is negative, where do you think it opens up? Well, if you're negative, you're frowning, so it opens down. So you're going to look to see if there's a positive or a negative. This h and k is very important because the h and k represents our vertex. It's actually the point h, k, where h is my x-coordinate and k is going to be my y-coordinate. So those are the three pieces we're going to look for as we graph a quadratic equation in vertex form, whether it opens up or down, and what the vertex is going to be. So let's do an example together. So the first thing to note is that every type of function has what's called a parent function. Okay? A parent function is really just the simplest type of equation that you could have for that specific function. So for a quadratic, the parent function is f of x equals x squared. So the parent function has a vertex at 0, 0. So I'm going to put that point on my graph. Whenever you're graphing a quadratic function, there's a pattern you can follow. So you're going to start at your vertex and you're going to go up 1 over 1, like when we're doing slope, and put a point. And then from there, you're going to go up 1, 2, 3, and over 1. And every quadratic is going to follow this pattern that we're going to work with in this unit. I could do the same thing on the other side. I can go up 1 to the left, up 3 to the left, and it creates this pattern. So now I can draw one smooth line through my function, and there's my parent function. So you're going to notice on this page that all of the parent functions are actually drawn in for you, and I highlighted them all in yellow. And we're going to use that parent function to figure out how is our new quadratic shifting. Is it shifting up, down, to the left, or to the right? So looking at my function, I need to figure out what my vertex is, what my hk is. So whenever you're finding the vertex, you're always going to take the h and you're going to switch the sign. So instead of a -1, it's really a +1 because h is just that number. It doesn't include this minus sign. So by itself, this is just a 1. So I'm switching the sign. And then I'm going to keep the sign for my y-coordinate. So my new vertex is going to be 1, negative 3. So I'm going to graph that. 1, negative 3. Since there's no negative sign here, it's positive. This parabola is going to open up. So I'm going to follow my pattern like I did for my parent function. Up 1 to the right 1, up 3 to the right 1. And then do it on the other side. Up 1 to the left 1, up 3 to the left 1. And then I'm going to draw my parabola in. So comparing to the parent function, I want to know, what's the transformation? And transformation is just a fancy word for saying, how did this new parabola move from its starting position? Well, if I look at the vertex, I could see that I went to the right 1 and then down 1, 2, 3. So that's what I'm going to write for the transformation. This parabola went to the right 1 and down 3. And you can actually look at the vertex too. It's a positive 1, so that is to the right, and it's a negative 3, so that means down 3. So that's what we're going to do for each example on this page. So I'm going to stop the video here. I recommend that you try the bottom 6 on your own, and then please look at my next video to see how to do these specific examples. My next video will also give you an example on how to complete your homework for this week. So see you at the next video.